Let's talk about how globe defenders claim they verify how the Earth rotates. One of the most cited pieces of evidence is the gyroscope. It's designed to maintain its orientation in space while the Earth rotates beneath it, producing a measurable drift rate that matches the sign of latitude formula. So at 48 degrees north latitude, that's approximately 11 degrees per hour. And at the poles, that would be 15 degrees per hour. At the equator, it's 0. That's presented as independent verification of Earth's rotation. Now, some people will say mechanical gyroscopes have been around for a century. Ships use them, aircraft use them. They work fine without computers. That's true. But what they don't tell you about mechanical gyroscopes is they're extraordinarily difficult and expensive to build precisely. Bearing friction causes drift, temperature changes cause drift, minor manufacturing imperfections cause drift. A mechanical gyroscope requires constant calibration and manual error correction to remain accurate over time. And this is why the industry moved towards digital systems, ring laser gyroscopes, fiber optic gyroscopes, MEMS sensors, all of which require computer processing to produce usable output. And that's where the primary sources become relevant. The latitude dependency is not a modern software invention. It's documented over a century ago. In 1915, Commander Louis Nulton of the U.S. Navy published an article in Naval Institute Proceedings documenting the Sperry gyroscopic compass. He states directly, reading from the primary source now, that each and every latitude requires its own particular rate of tilting and resulting precession in order to turn the axis into the meridian and keep the compass pointing north. The German compass of that era was physically built and calibrated for 50 degrees north latitude. For every other latitude, navigators had to manually shift the lubber's line to correct the error. At 60 degrees south, the required correction was 3 degrees 48 minutes westerly. Manual, latitude-specific, required correction. Keyword manual. It's not a bug in the system. It's a documented feature going back over a century. The instrument requires latitude input to function accurately. That was true in 1915 with mechanical gyroscopes, and it's true today. Kenneth Britting's Inertial Navigation Systems Analysis, a foundational aerospace engineering text, confirms that when a modern inertial navigation system initializes, latitude is input during that process and used to compute expected Earth rate components for deterministic subtraction. In plain language, the gyroscope doesn't operate in a vacuum. It feeds into a computer system. That system is told where it is, calculates what drift rate the gyroscope should be seeing based on location, and subtracts that expected value from the raw data. And here's the important question that raises. If latitude goes into the system during initialization, and that latitude is used to calculate the expected drift rate, and that expected drift rate is then subtracted from the raw data, then what is the output actually measuring? Is it independently detecting Earth's rotation? Or is it confirming the calculation the system was initialized with? Britting's book also notes something worth paying attention to. Azimuth alignment accuracy decreases near the poles because the horizontal component of Earth's rotation, the cosine of the latitude, approaches 0 at high latitudes. In other words, the closer you get to the pole or high latitudes, the harder it is for the system to physically determine which way north is on its own, because that directional signal vanishes into instrument noise. Think about what that means. At the very location where the globe model predicts maximum rotational drift, 15 degrees per hour, the instrument loses its independent ability to orient itself and becomes entirely dependent on pre-computed coordinate software to tell it where it is. I'm not telling you what to conclude. I'm just showing you what primary sources confirm. A 1915 Naval Institute Proceedings article and a foundational aerospace engineering text about how these systems actually initialize and calibrate. The question of whether that process constitutes independent verification or circular confirmation is one worth asking. That's why I always go down to the bones, the primary sources. Commander Louis Nulton, Naval Institute Proceedings, September 1915. Kenneth Britting, Inertial Navigation Systems Analysis. Look them up yourself.